Hello, everyone. In this video, I will explain the paper Theory of AI-Driven Scheduling, or TAIS, a service-oriented scheduling framework by integrating the theory of constraints and AI. It's written by me, Marzieh Khakifirooz, Professor Michel Fathi, and Professor Alexandre Dolgui, and published in the International Journal of Production Research. We know that most schedules fail not because people are careless, but because the world changes after the schedule is made. The paper introduced TAIS, the theory of AI-driven scheduling. TAIS combined classic operations idea, the theory of constraint, with artificial intelligence. The goal is not to replace managers with algorithms. The goal is to build a scheduling system that can see constraints, adjust priority, learn from feedback, and keep the whole operations moving. Let's think about a hospital, a factory, a repair center, an airport, or a delivery network. Every morning, there's a plan. People know what machines, rooms, drivers, nurses, technicians, or service teams should do. Then reality arrives. A machine breaks, suppliers late, demand jump, or customers ask for a custom order, or a staff member is absent. Very quickly, that beautiful schedules become a negotiation between urgency and capacity. The hard truth is that in many organizations, scheduling is still treated like a calendar problem, when it is really a constraint that management is the management problem. The theory of constraints gives us the practical lens. It says, do not try to optimize everything at once. Find the constraint and the factor that limits the whole system. It might be a machine, a person, a policy, missing material, a data delay, or even a decision rule. Once you find it, protect it. Use it well. Align the other work around it. Then elevate it if needed. This is a powerful idea because it forces managers to focus. But classic theory of constraints was not designed for the world where constraints can move every hour and where thousands of the signals are available in real time. This is where AI can become useful. AI can watch data stream, detect patterns, predict future constraints, test possible actions, and update decisions as continue changing. But AI by itself is not enough. An algorithm may optimize the wrong target, create unfair schedule, or produce recommendation that people do not trust them. TAIS is important here because it does not say let AI schedule everything. It said keep the managerial decision of the theory of constraint and add AI so the system becomes more adaptive, predictive, and service-oriented. This is the pitch of the paper in one sentence. TAIS turns a scheduling from a static plan into a continuously learning management system. Let us now unpack the paper. The starting point in the paper is the theory of constraint. In a simple language, theory of constraints asks 5 questions. First, what is the limiting? What is limiting the system? Second, how can we use that limiting resources as effectively as possible? Third, how should everything else be aligned around it? Fourth, do we need to increase its capacity or redesign the process? Fifth, once the constraint is solved, what is the next constraint? This loop is useful because it prevents a scatter improvement. Instead of fixing 10 visible problems, managers focus on few problems that actually control throughput, service speed, cost, and customer responsiveness, and a huge part of the system. TAIS keep the 5 theory of constraints step, but makes them data-driven and adaptive. It adds real-time monitoring, predictive analytics, machine learning, simulation, reinforcement learning, and human-AI collaboration. The key difference is speed and scope. Traditional scheduling often depends on manual analysis, fixed rules, or historical averages. TAIS can use historical data, current condition, user preference, process logs, and sensor information together. It can identify obvious constraints and also hidden ones. It can recommend immediate adjustment and also longer-term changes. But the paper is careful here because TAIS still needs data quality, explainability, governance, security, and expert validation. Without those, AI-driven scheduling can become fast but wrong. The first stage is identification. In traditional theory of constraints, people map the process and look for the bottleneck. TAIS does do as well, but adds AI tools. For example, process mining can read events logs from the system, such as ERP or workflow software, and reconstruct how work really flows. Anomaly detection can identify unusual delays. Predictive models can warn what a future workload will exceed the capacity, and the digital twin can simulate what may happen under different conditions. However, the paper doesn't treat AI as automatically correct. After AI identifies a possible constraint, experts should validate it. That matters because data can show a pattern, but experienced people can explain whether that pattern is a real problem or is just a data artifact. After identifying the constraint, TAIS asks, how can we get more value from that constraint? In theory of constraint language, this is exploitation. If the constraint is a machine, we want it working on the right task, not waiting for material or switching unnecessary between jobs. If the constraint is a specialist, we want that person focus on its work only, not doing something else. TAIS improve this stage by using real-time data or adjust priority, reduce waiting time, recommend maintenance, and allocate resources. It can also simulate alternative scheduling before applying them. The practical message is simple. Do not immediately buy more capacity. First, make sure that the secure capacity is not being wasted. The third stage is decision-making and subordination. The word subordination may sound technical, but the idea is simple. If one resource controls the system, then other resources should not run independently in a way that overload it, starve it, or create excess work. In a factory, upstream work should not release more jobs than the constraint can handle. In a hospital, appointment system should consider room availability, staff capacity, and critical equipment. TAIS support this by continuously evaluating the effect of each scheduling choice on the constraint. It can update task priority, coordinate upstream and downstream activities, and communicate recommendation to the stakeholder in a form that they can understand. Sometimes using the constraint there is not just enough. Then the system must elevate or scale them. Elevation means changing the system so the constraints is weakened or removed. That may require training staff, redesigning process, investing in equipment, automating repetitive tasks, or collaborating with external partners. TAIS helps because it can forecast the effect of those changes before the organization commits resources. It can run simulation, estimate demand scenario, and compare strategies. This is important because capacity investments are expensive. The promise of TAIS is not only better daily scheduling, but better strategic capacity planning. It helps managers ask which change will actually improve the whole system, not just one local metric. The fifth stage is continuous improvement. In classic theory of constraint, once one constraint is improved, the organization looks for the next one. TAIS keeps that logic but makes the learning cycle much faster. Each schedule produces data, and then we'll ask, did this plan work? Where did delays occur? Which priority rules helps? Which recommendation failed? Where customers serves faster? Where employee overloaded? These signals flow back into the system. Machine learning can refine the prediction model. Manager can update rules and assumption, and dashboard can alert user when a new bottleneck appears. This turns the scheduling into an ongoing learning process instead of repeated emergency responses. A major contribution of the paper is that TAIS is not only a set of algorithms, it is presented as a service-oriented framework. That means it must work inside real organization with the real users, data system, security requirements, and governance process. The paper adds 3 service layers around the 5 theory of constraint-based steps. First, real-time responsiveness and dynamic scheduling. So the system can adjust as conditions change. Second, life cycle management and governance. So models, data version, testing, deployment, and performance are controlled over time. Third, security and compliance, because the scheduling data may include sensitive information about workers, patients, customers, production plans, and supply chain. These layers make TAIS practical rather than just technical. The paper discussed several industry settings, but 4 are especially important. The first is the low volume, high variability manufacturing, where each order may be different, but we have the very diverse orders from the customers. The second is high-tech industry, where expensive equipment, precision, and fast innovations make a scheduling different. The third is the supply chain intensive operations, such as automotive or consumer goods, where delay can propagate across the supplier, logistic, inventory, and production. The fourth is the service cost sector with the high variable demand, such as healthcare, maintenance, and IT services. These environments share one feature, and that's that the schedule cannot be solved once and left alone. It must keep sensing, learning, and adapting. Let me close this video with 3 takeaways from the paper. First, the paper reframed scheduling. Scheduling is not only about assigning tasks to time slots. It is about managing the constraints that control the system performance. Second, AI is valuable when it strengthens with this managerial logic. Seeing constraint earlier, predicting pressure before it becomes failure, and helping people make better decisions. Third, TAIS reminds us that technology needs a structure. Data quality, human expertise, explainability, governance, security, and continuous improvement are not side issues. They are part of the scheduling system. And in one sentence, TAIS is a framework for making a scheduling adaptive, constraint-aware, and service-ready. Thank you for watching.